Expecting we kill the lines, the most entrancing star I perceive is the star that could be dumbfounding in our sky. It is this one, Betelgeuse or Scarapress. It's a red monster star, and on the far-off probability that you put it where the Sun is, it would associate with the circle of Jupiter. It's huge, particularly flighty, and going to detonate. It's not so clear as it shows up in the universe. These shocking occasions, like the most unquestionably monstrous starbursts, could shake all that we see and don't see, fundamentally. In any case, Betelgeuse has been viewed as a sign, a red, very monster star that is boundlessly more gigantic than our Sun. Brian Cox and other space specialists figure it could go supernova at any second. People are for the most part terrified of what will occur, since the James Webb Space Telescope is taking exceptional photos of the star. When precisely will Betelgeuse become a supernova, and how enormous of an impact will it have on Earth? We should figure it out. The star in the heavenly body Orion, which shines so brilliantly that even people from old times saw it, is Betelgeuse. Betelgeuse, situated on the eastern shoulder of the heavenly body, is the second largest star in Orion. Its name comes from this component, the monster's shoulder. It is potentially one of the most glorious stars in the night sky. On top of being particularly splendid, the star is also an odd shade of red, which, as we will see, suggests trouble. We've had some significant awareness of Betelgeuse for quite a while. A Greek cosmologist named Tmy also concentrated on it around that time. The central thing people recognized about stars was their variety. Tmy said it was an orange tint, an admonition. Researchers have been zeroing in on the star considerably more intently of late and now have a strong idea of what works everything out such that remarkably brilliant. One of these properties is that the star's brightness changes fundamentally, with an extent of 0.6. Betelgeuse is a variable star, meaning its brightness fluctuates after some time. Anyway, in 2019, researchers saw something surprising. Betelgeuse was acting strangely. While it didn't quit sparkling, it turned out to be altogether less brilliant, with its brightness dropping to a size of 1.6. Researchers immediately began exploring why the 10th most brilliant star overhead was darkening so definitely. Their examination prompted a frightening end. In light of recent signs, researchers say that Betelgeuse could go supernova at any second. Brian Cox, an unmistakable physicist and teacher at the University of Manchester, stressed this chance. He stated that Betelgeuse seems to be a ticking delayed bomb, all set off without advance notice. The James Webb Space Telescope has given significant proof to support this claim. The inquisitive signs of Betelgeuse have shown a few strange behaviors recently, raising alarm among scientists. For instance, one dimming in February 2021, Betelgeuse reached a very low brightness of 1.61. This was soon after the extraordinary dimming event of 2019, when it lost an uncommon measure of brilliance, dropping by 1.2 magnitudes. Two changes in brightness cycles, the star patterns of lighting up and darkening, now happen twice as quickly as they used to. 3. Surface mass ejections. The James Webb Space Telescope has seen that Betelgeuse shot out a surface mass comparable to 400 billion times that of a typical coronal mass ejection from our Sun. These discoveries suggest something unprecedented is going on. Betelgeuse is currently 150% more brilliant than normal, making it the 7th most brilliant star visible overhead. This sudden increase in brightness has started extra inquiries about its future. The red tone of Betelgeuse demonstrates that it is a red supergiant star, a late stage in a star's life cycle. The star's surface temperature is around 3,500 Kelvin, much cooler than the Sun's 5,500 Kelvin. In spite of being cooler, Betelgeuse is fundamentally bigger and ready to detonate. A perishing star like Betelgeuse will normally fade over time. Anyway, its sporadic behavior, like the incredible dimming, has made researchers increasingly concerned. Many telescopes are now focused on the star to monitor these peculiarities. Using the James Webb Space Telescope, this instrument has been instrumental in uncovering basic information about Betelgeuse. Its pictures of the Great Dimming Event showed that the star went through a surface mass ejection, dissimilar to anything seen prior to. Utilizing its advanced capacities, the telescope can notice light waves and frequencies undetectable to the natural eye. Scientists are now breaking down the dust mists forming on Betelgeuse's surface. This discovery, combined with the star's extraordinary brightness changes, suggests it could be approaching a mind-blowing finish as a star. The chance of bug juice detonating as a supernova has captivated and frightened researchers. A star should regularly have a mass no less than 8 to 15 times that of the Sun to take its life as a supernova. Bug juice, being around 10 to 15 times the Sun's mass, fits this model. When it detonates, the event will be completely dynamite. A supernova discharge is strong to the point that bug juice will probably dominate the Moon in the night sky for quite a long time, or even a very long time. Nevertheless, its closeness, in grandiose terms, around 640 light-years from Earth, will represent no immediate danger to us because of the tremendous distance. Anyway, it will give a remarkable opportunity for astronomers to concentrate on the life cycle of massive stars. Proof of a looming supernova. The Great Dimming of 2019 to 2020 ignited worldwide attention. Researchers initially hypothesized that the dimming was brought about by a dust cloud or a gigantic convective cell on the star's surface. Anyway, new information suggests that bug juice may be in the last stages of its development. One enlightenment lies in its mass loss events. Bug juice has been noticed catapulting material into space, making a thick dust storm around it. This mass launch is believed to be connected to the possible breakdown of the star's core, a vital stage before a supernova. What happens when bug juice detonates? When bug juice reaches the finish of its life, it will go through core breakdown. The cycle begins when the star runs out of atomic fuel, making the outward pressure from fusion stop. Gravity will then assume control, compacting the core to where it can never again support itself. This results in a gigantic blast, a supernova. The blast will release a colossal amount of energy, producing light, intensity, and particles across the system. Bug juice will change into either a neutron star or a black hole, depending on the remaining mass after the blast. While the supernova won't hurt Earth, it will be an awe-inspiring celestial event, visible even during the daytime. The light transmitted will require approximately 640 years to contact us, meaning the blast might have already occurred, and we are simply waiting for the light to arrive. Astronomers continue to observe bug juice with cutting-edge instruments like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based observatories. These instruments allow researchers to track its brightness, temperature, and mass loss events in real time. One of the key objectives is to determine the specific timetable for bug juice's supernova. While researchers believe it could happen any time in the next 100,000 years, they remain cautious about making exact predictions. Bug juice's behavior is both eccentric and entrancing, offering a rare look into the life of a perishing star. An enormous perspective. The study of bug juice helps remind us of the infinity and dynamism of the universe. Stars like bug juice are pivotal to the vast ecosystem, as their blasts release heavy elements like carbon, oxygen, and iron, the fundamental building blocks of planets and life. When bug juice finally detonates, it will mark the end of one star's life and the beginning of innumerable new possibilities in the system. For the time being, humankind watches and waits, wondering about the marvels of the universe, not knowing when bug juice will die. Experts are still observing it because they don't know when it will go supernova. Researchers believe that bug juice is considerably larger than the Sun and that the brilliant red star will shine for the next 10 years. However, given the various extraordinary things occurring with the star, it's challenging to say if this statement will still hold true after the Great Dimming. Specialists don't believe bug juice will detonate anytime soon. If bug juice explodes, it will be the first supernova we notice for ourselves, since Johannes Kepler did in 1604. Experts also don't want this to happen soon, as they are still focusing on the star's extraordinary behavior. Regardless of when bug juice will ultimately detonate, specialists are uncertain about when exactly it will occur. If we look at the universe without the limitations of human time periods, bug juice is perhaps one of the most captivating stars, and maybe the most shocking in our sky. Frequently alluded to as Betelgeuse, this red giant star, if placed where the Sun is, would stretch out to Jupiter's orbit. This marvelously epic and shaky star is very close to a blast. The universe, however, doesn't work in such direct terms. Staggering events like the dreaded starbursts could fundamentally modify all that we know. Recent discoveries on bug juice. Bug juice has offered captivating signs as a red supergiant star, several times the size of our Sun stargazers, including Brian Cox, believe it could go supernova at any moment. The concern lies in the consequences of such an event, especially since the James Webb Space Telescope has captured disturbing pictures of the star. So, when exactly will bug juice become a supernova, and what effect will it have on Earth? Recently, the star turned out to be significantly dimmer, shining at only 1.6% of its previous brightness. Analysts quickly began exploring why the 10th most brilliant star in our sky was displaying such strange behavior. They issued a frightening announcement based on their research. Warning that Betelgeuse's behavior suggests it could be on the brink of going supernova. The star's sudden and unexpected dimming, combined with other peculiarities like its increased brightness fluctuations, has raised concerns among astronomers. The strange events surrounding Betelgeuse have caused both fascination and apprehension, as the star's behavior could signal the beginning of its final stages. Astrophysicists are closely monitoring Betelgeuse using a variety of advanced tools, including the James Webb Space Telescope and other observatories around the world. These instruments provide crucial data that could help scientists better understand the star's impending fate. One of the most significant concerns is the possibility that Betelgeuse is losing mass at an accelerated rate, which could be a precursor to its eventual collapse into a supernova. As the star continues to lose mass, it may be shedding material that could eventually form a thick cloud of gas and dust around it. This could obscure our view of the star, making it more difficult for astronomers to study its final moments. However, the data gathered so far suggests that the star's core may be nearing the point where it can no longer sustain itself. When that happens, gravity will cause the star to collapse, triggering a massive explosion. The exact timeline for when Betelgeuse will go supernova remains uncertain. While some researchers predict that it could happen within the next 100,000 years, others believe it could occur much sooner. Regardless of when it happens, the event will be one of the most dramatic and awe-inspiring moments in the history of astronomy. It will release an enormous amount of energy, and its light could be visible from Earth, even during the day. While the supernova won't directly impact our planet, it will provide an invaluable opportunity for scientists to study the life cycle of massive stars. The explosion will also contribute to the creation of heavy elements, such as iron and nickel, which are crucial for the formation of planets and life as we know it. In a sense, the death of Betelgeuse will mark the beginning of new life in the universe, as the materials from the explosion will eventually be incorporated into the next generation of stars and planets. As we wait for the inevitable explosion, researchers will continue to study Betelgeuse and other similar stars. By understanding how these stars evolve and die, scientists can gain valuable insights into the broader workings of the universe. The fate of Betelgeuse, like the fate of all stars, is a reminder of the vastness and impermanence of the cosmos. In the end, the study of stars like Betelgeuse helps us to better understand our place in the universe. While the star may eventually explode in a spectacular display of energy, its death will also pave the way for new beginnings in the cosmos. And for now, we watch and wait, in awe of the wonders of the universe.